Hello PreCalc students, this is your Unit 4 review. You're reviewing for your Unit 4 test. The first set of problems, these are problems from the unit circle from Unit 1, but before we can talk about doing inverse trig, which is backwards trig, we're going to talk about doing the regular trig, the forwards trig. So remember that the cosine is the x value of the coordinate on the unit circle. So if you look at your unit circle on the last page, you can see that the x value at 5 pi over 6 is negative root 3 over 2. For number 2, the cosecant is the reciprocal of the sine. So if the sine of pi over 3, that would be the y value. If the sine is root 3 over 2, then the cosecant is going to be the reciprocal. So cosecant pi over 3 is 2 over root 3, which you can rationalize by multiplying by root 3 over root 3, and your final answer will be 2 root 3 over 3. All right, for problem 3, we're doing the sine of negative 5 pi over 6. Now, you need to think about this as an angle on the unit circle, so one way you can do that is to visualize your unit circle and realize that if you head backwards 5 pi over 6, you are going to land over here at 7 pi over 6. Positive 7 pi over 6 is coterminal with negative 5 pi over 6. But the other thing you can do is algebraically find your answer by just taking negative 5 pi over 6 and adding 2 pi. With a common denominator, 2 pi would be 12 pi over 6. So you can see again that it would be 7 pi over 6. So when we're finding the sine of negative 5 pi over 6, that's the same as the sine of 7 pi over 6. The sine is the y value of that coordinate, and the y value there is negative 1/2. If you're having any trouble remembering these values from your unit circle, then you want to work on memorizing your unit circle again. Alright, in problem 4 we're doing the tangent of negative pi over 3. So using one of the strategies that you used in number 3, you have to figure out where that would be on the unit circle. So if I go backwards pi over 3, I'm going to end up right here, and that would be 5 pi over 3. Again, you could just take negative pi over 3 and add 2 pi to it, finding a common denominator, and you would also find 5 pi over 3. So I'm doing the tangent of 5 pi over 3. Tangent is the y value over the x value, so my y value is negative root 3 over 2, and my x value is positive 1/2. So the over 2's will cancel. I have negative root 3 divided by 1, which is just negative root 3. Secant is the reciprocal of the cosine, so if I find that the cosine of 2 pi over 3 is equal to negative 1/2, then the secant is going to be the reciprocal of negative 1/2. So the secant of 2 pi over 3 is negative 2. And the cotangent is the x value over the y value. So your x value at pi over 4 is root 2 over 2, and your y value is also root 2 over 2. And when you divide by the same number, you're going to get a final answer of 1. Okay, down here we're starting to talk about inverse trig. So remember that with inverse trig, every input can have only one output, so we had to restrict the quadrants for each function so that we didn't get more than one output. So the functions that were defined from negative pi over 2 to pi over 2 were sine and cosecant. Of course, values that would make the cosecant undefined were not included, but we didn't write that there. And then the same for cotangent. The same for tangent. In tangent, I know that negative pi over 2 and pi over 2 are undefined, so I'm just going to leave those out. Okay, then the ones that were going from 0 to pi are cosine, inverse secant, of course leaving out any values that would make that undefined, and inverse cotangent. And the whole reason behind doing this chart is just to help you figure out where to find your answers when you solve the problems below. So negative pi over 2 to pi over 2 are quadrants 1 and 4 for this one, for this one, and for this one. And then if you have answers 0 to pi, your answers are quadrants 1 and 2. So inverse trig will never have an answer in quadrant 3. Okay, so now let's use this to figure out where our answers are. And when I'm answering problem 8, I'm trying to figure out what angle, and actually for all of these I'm trying to figure out what angle. What angle has a cosine of 1? Well, the cosine is the x value, so on the unit circle I'm thinking about where is the x value 1, and it's right here at 0 degrees or 0 radians. For number 9, I want to know what angle has a tangent of negative root 3 over 3. Now tangents could be in the first quadrant or in the fourth quadrant, and if this is negative, it's got to be in the fourth quadrant. So I'm trying to think of what angle that is that I would divide the y by the x and get negative root 3 over 3. I'm thinking that my angle is going to be negative pi over 6, and I'm just going to check and see if I'm right. Remember that I have to write this as negative pi over 6. I cannot write it as 11 pi over 6 because 11 pi over 6 is not on the interval for tangent. Tangent has to be between negative pi over 2 and positive pi over 2. So let me just check my answer now. My y value is negative 1/2. My x value is root 3 over 2. The over 2's will cancel, and I have negative 1 over root 3, which when I rationalize should give me negative root 3 over 3. Yes. But remember that the answer is the angle. In problem 10, I need to know what angle has a sine of root 2 over 2. And that's in the first quadrant. And if you check your unit circle to see which angle has a y value of root 2 over 2, you should get 45 degrees or pi over 4. Okay. Down here I want to know what angle has a tangent of negative 1. Again, that's going to have to be in the fourth quadrant for inverse tangent. And if I want the y divided by the x to be negative 1, they're going to be the same value except for opposites. So that happens at negative pi over 4. Because I'm going to get negative root 2 over 2 divided by positive root 2 over 2, which gives me negative pi over 4. If I have something like an inverse secant, I'm going to change that to the inverse cosine of the reciprocal. So 1 over root 2. Now, I know 1 over root 2 would have to be rationalized. If I multiply it by root 2 over 2, I get inverse cosine of root 2 over 2. Okay, so the angle that has a cosine of root 2 over 2 is 45 degrees, or pi over 4. Alright, an inverse cotangent of root 3. So remember that the cotangent is the y over the x. So you think of which angle you think it's going to be, that y over x, I'm sorry, I said y over x, that's actually x over y. I need my eraser. Okay, so it's the x over the y. So I'm thinking it's going to be pi over 6. And I'm going to check that answer by dividing the x by the y. The x is root 3 over 2. The y is 1/2. The over 2's cancel. I get root 3 over 1, which is root 3. So my answer is pi over 6. For the composite inverse trig problems, you start on the inside and then you do the outside. So first I'm trying to find out what angle has a sine of negative 1/2, and my answer has to be between negative pi over 2 and pi over 2. So on the unit circle, I can see the spot where the y value is negative 1/2. It's right here, but instead of writing it as 11 pi over 6, I need to write negative pi over 6. Now I want to find the tangent of that angle. Well, the tangent is the y value divided by the x value. So that would be negative 1/2 divided by root 3 over 2. So the over 2's cancel. I have negative 1 over root 3, and I will rationalize it. And I get negative root 3 over 3. All right, problem 15. I need the cosine of negative pi over 2. So negative pi over 2 is down here. The cosine is the x value, so that's 0. Inverse sine, 0. Actually, I think I misread this. It doesn't say negative pi over 2, it says negative pi over 3. So let's erase that and go back to the marker. Okay, so negative pi over 3 is here, and the cosine of that is 1/2. So now I need to know what angle has a sine of positive 1/2, and that angle's in the first quadrant. It's pi over 6. All right, for 16, I need to know what angle has a cosine of negative root 3 over 2. And remember, inverse cosine can only happen in the first quadrant and second quadrant. So if it's negative, it's going to be in the second quadrant. And negative root 3 over 2 is my x coordinate, so my angle should be 5 pi over 6. So I want to know what angle has a cosecant, or I want to know what is the cosecant of 5 pi over 6. Well, the sine of 5 pi over 6 is 1/2, because that's the y value, so I need to take the reciprocal of 1/2 and flip that upside down, so I just get 2. When I get to the problem 17, I realize that 3/5 is nowhere on the unit circle, so this is when you start drawing pictures. I need an angle where the sine is 3/5, and since 3/5 is positive, that's going to be in the first quadrant. So 3 is the opposite, and 5 is the hypotenuse, opposite over hypotenuse. You can do the Pythagorean theorem to find the third side, or you can realize that this is a 3, 4, 5 triangle and just fill the 4 in. Double check to make sure positive 4 makes sense. It does. So here's my theta. So inverse sine of 3/5, I never find the angle, but I do know that all of this represents theta. So I'm finding the cosine of theta now. Cosine is adjacent over hypotenuse, so your final answer is 4/5. Okay, in problem 18, I need to figure out what angle has a cosine of 12 over 13. So 12 would be the adjacent, and 13 would be the hypotenuse. And here's your theta. So you can do Pythagorean theorem to find the missing side, or you can know that this is a 5, 12, 13 triangle. So now all of this represents theta, and we need to find the tangent of theta. Well, the tangent is the opposite over the adjacent, so your final answer is 5/12. Okay, in 19, there's an angle that has a secant of negative 13 over 5. Secant is negative in the second quadrant, so this means secant's reciprocal of cosine, so this will be hypotenuse over adjacent. Hypotenuse over adjacent. So that means our opposite side is 12. The negative must belong to the 5 over here. And all of this represents theta. So the tangent of theta is going to be the opposite over the adjacent. Alright, so we're moving on from inverse trig to solving trig equations. When you solve equations, you can't have more than one answer. So you need all answers. General solution, that's when you do the plus 2 pi k or plus pi k, depending on what you're talking about. So for cosine equals negative root 2 over 2, that happens in two places. That happens at 3 pi over 4, and it happens also at 5 pi over 4. but you want to represent the answers that you get when you go around the circle, a full circle from 3, 5, or 4, or even going backwards a full circle from 3, 5, or 4. And remember, you can do circles as many times as you want, so there are really an infinite number of answers. So you can add 2 pi any positive or negative amount of times that you want. So as long as you know that k is an integer, then you can add any number of 2 pi's or any negative number of 2 pi's you want to both answers. Okay, in 21 we need to isolate the secant. So I have 3 secant squared x equals 4 after I add 4 to both sides, and then divide by 3 on both sides. So I have secant squared x equals 4/3. And then when you square root both sides, you need to remember the plus or minus. So I'm going to do square root and plus or minus square root. So I get secant x equals plus or minus, the square root of 4 is 2, and over the square root of 3. Now I could rationalize that, but because secant is a reciprocal function, I'm just going to take the reciprocal. So if that's the secant, then the cosine is plus or minus root 3 over 2. So there are 4 places on the unit circle where the cosine would be positive root 3 over 2 or negative root 3 over 2, and you need to write all of those answers with a plus 2 pi k. So let me start over here. So I have space. X is going to equal pi over 6 plus 2 pi k. X is going to equal 5 pi over 6 plus 2 pi k. X equals 7 pi over 6 plus 2 pi k, and the last one is at 11 pi over 6 plus 2 pi k. Alright, in problem 22, it looks like we're going to need to do a little bit of factoring. And you may not have seen a problem like this before, but that's okay, because we're going to work through it together. You want to make one side 0, so I'm going to subtract this 1, and I have 2 sine x cosine x minus 2 cosine x plus sine x minus 1 equals 0. Okay, and then this is called factoring by grouping. When you have 1, 2, 3, 4 terms, sometimes factoring by grouping will work for you. You want to group together the first 2 terms and the last 2 terms. So in the first 2 terms, you take a common factor out. So both terms have 2, and both terms have cosine. So I'm factoring out a common factor of 2 cosine x. Now, if I divide each of these by 2 cosine x, the first term leaves me with sine x, and the second term leaves me with 1, because that's exactly what I factored out. The second pair of factors does not really have a common factor, so I'm just going to factor out the number 1, and I'm left with sine x minus 1, and I still have equals 0. So both of these terms are being multiplied by sine x minus 1, so sine x minus 1 is one of your factors. And then the other factor is what we're being multiplied by. So sine x minus 1 is multiplied by 2 cos x, and also by plus 1. So then I want to set both of those factors equal to 0. If I have, let's see if I can separate this out from the previous problem. If I have sine x minus 1 equals 0, then I get sine x equals 1. And if I have 2 cos x plus 1 equals 0, I'll subtract the 1 and divide by 2, and I get cos x equals negative 1/2. So the places on the unit circle where the sign is 1, that just happens at pi over 2. So let me see if I can write that answer down here. X equals pi over 2 plus 2 pi k. And where the cosine is negative 1/2, that happens in 2 places. X equals 2 pi over 3 plus 2 pi k, and x equals 4 pi over 3 plus 2 pi k. So there are 3 sets of answers. 1, 2, 3. All right, down here we're supposed to be giving the answers from 0 to 2 pi. So let's start over here. We have a common factor of cosine, so we factor out that common factor. And we're left with cos x plus 1. Cosine times cos x gives you the cos squared. Cos x times 1 gives you this one. Next, you set both factors equal to 0. So cosine of x equals 0. Cos x plus 1 equals 0. This one's ready. This one you need to subtract 1 on both sides. Cos x equals negative 1. So the places on the unit circle where the cosine is 0, that's the x value, are x equals 0. X equals pi over 2 plus 2 pi k, and x equals 3 pi over 2 plus 2 pi k. And the places on the unit circle where the x is negative 1 is x equals pi plus 2 pi k. But because we're not asked for the general solution here, we're asked for the answers from 0 to 2 pi, you just want to write the answers without their plus 2 pi k. So my set of answers would be pi over 2, and pi, and 3 pi over 2. Okay, next one, we need to isolate the sign. So I'm going to divide by 4 on both sides, and I get sine squared x equals 3/4. And then I'm going to plus or minus the square root, so I get sine x equals plus or minus square root of 3/4. And sine x equals plus or minus square root of 3, but the square root of 4 is 2. So there are 4 places on the unit circle where the sign is positive root 3 over 2 or negative root 3 over 2. And I'm not going to bother writing the general solution this time. I'm just going to list all 4 of those places. So that happens at pi over 3, basically the whole over 3 family. 2 pi over 3, 4 pi over 3, and 5 pi over 3. Alright, secant squared x equals 4. So we'll do plus or minus the square root on both sides. And secant x is equal to plus or minus square root of 4. So it equals plus or minus 2. So secant is the reciprocal of the cosine. So that means we're looking for the places where the cosine of x is plus or minus reciprocal of 2, which is 1/2. So cosine's the x value. You're looking to see where does the x value equal 1/2. Turns out those are the same places as where the sine is root 3 over 2. So it's the same list of answers. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Alright, in problem 26, you're going to make one side 0 by subtracting 1 on both sides. So you have 2 sine squared x plus sine x minus 1 equals 0. So at this point, this looks like a trinomial that you could factor, and we are going to factor it, but for some people it's easier to look at this if you do a u substitution. So if you let u equal sine x, then you can substitute u for the sine x. So you have now just 2u squared plus u minus 1 equals 0. And now this looks like a problem from Algebra 2. You want to factor this by finding 2 numbers that multiply to the first times the last. So they have to multiply to negative 2. And they have to add to the coefficient of the middle term. Since that's just u, that would be 1u. So they have to add to 1. Okay, let's see. So those numbers would be 2 and negative 1. And what you do is you take the 2 and negative 1 and you replace the 1u with 2u minus 1u. So instead of 1u, I'm writing 2u and negative 1u. And I chose those numbers because they are the numbers that multiply to negative 2 and add to 1. Then you bring the 2u squared down, and you bring the minus 1 down, and you factor by grouping. From the first two terms, you have a common factor of 2u, so take the 2u out, and you have u plus 1. From the second two terms, you have a common factor of minus 1, and you have u plus 1. So your factors are 2u minus 1 times u plus 1. So now if you set those back to be sine, you have 2 sine x minus 1 and sine x plus 1 equals 0. So maybe I'll use the space over here and then I'll do another problem on another page. Okay, so let's forget about this for a second. Push this over here. I have 2 sine x minus 1 times sine x plus 1 equals 0. So I put the sine x back where the u was. And now I set my factors equal to 0. 2 sine x minus 1 equals 0. Sine x plus 1 equals 0. And when I solve this one, I add the 1 and divide by 2, so I get sine x equals 1/2. And on this one, I subtract the 1, and I get sine x equals -1. So I'm still looking for answers only between 0 and 2 pi, so the sine is 1/2 at pi over 6 and 5 pi over 6. And the sine is -1 at 3 pi over 2. Alright, I think I have space to do 28, but for 27 I'm going to need to go to a new page. So let's add a new page in here, and we'll write problem 27. Cosine 3x equals root 2 over 2. Alright, so there has to be some angle where the cosine is root 2 over 2, and there are actually two angles. So that would be in the first quadrant at pi over 4, and in the fourth quadrant at 7 pi over 4. Now, whenever you have multiple angles, a 3x, a 2x, a 4x, there are going to actually be extra solutions even on this small interval of 0 to 2 pi. The way you find them is to write this as a general solution plus 2 pi k plus 2 pi k. And then you do times 1/3 to eliminate the 3. So I have 1/3 times 3x equals 1/3 times pi over 4 plus 2 pi k. 1/3 times 3x equals 1/3 times 7 pi over 4 plus 2 pi k. So the 1/3 times 3 is going to give you just 1x. Over here I get pi over 12 plus 2 pi over 3k. And let's see again, I get x equals 7 pi over 12 plus 2 pi over 3k. Alright, so I do get solutions of pi over 12 and 7 pi over 12, but there are more solutions, and the way I find them is by adding 2/3 pi. And usually, if this number is 3, I'm going to get 3 times as many solutions as I would usually get. So I'm going to add 2 pi over 3 twice. I need a common denominator, so I'm going to add it the first time, pi over 12. If I multiply numerator and denominator by 4, I'll get 8 pi over 12. Alright, so that gives me 9 pi over 12, which I'm going to have to simplify, but before I simplify it, let's just add 2/3 pi again. And I get 17 pi over 12. Alright, so this is an answer. And when I added 2/3 pi, I got this answer, which still needs simplifying. I'm getting there. And then this is an answer. Okay, 7 pi over 12 is also an answer, and I'm going to add 2 pi over 3 to that. So 7 pi over 12 plus, with a common denominator, this is 8 pi over 12. So that gives me 15 pi over 12. That can be simplified, but I'm going to hold on to that for a second. and add 8 pi over 12 again, and that gives me 23 pi over 12. Alright, so this is an answer, 7 pi over 12, 15 pi over 12 is an answer, and 23 pi over 12 is an answer. So these are all answers. Now I'm going to write them down and I'm going to simplify the two that need simplifying. Pi over 12. 9 pi over 12 simplifies to 3 pi over 4. 17 pi over 12. 7 pi over 12. 15 pi over 12 simplifies to 3 pi over 2. Is that right? Divide it by 3. No, not quite. Try again. Alright, I'll divide 15 by 3, I get 5 pi. And divide 12 by 3, I get 5 pi over 4. And 23 pi over 12. Okay? So the time when you have to keep adding to find multiple answers is when you have a 3x in here, or a 2x or a 4x. Alright, let's go back to problem 28. Problem 28, I have cosine and I have sine, and that is the issue here because it's very hard to solve when you have two different trig functions. So I know that sine squared x plus cos squared x equals 1. So what I can do if I want to solve that for cos squared is subtract sine squared on both sides, and now I know that cos squared x equals 1 minus sine squared x. So I'm going to substitute 1 minus sine squared x for the cos squared x. 2 times 1 minus sine squared x. Let's see if I can separate this one. Equals 2 plus sine x. Now the other thing I need to do is make one side 0. So I'm going to distribute this side. I get 2 minus 2 sine squared x. And then I'm going to subtract the 2 from both sides and subtract the sine x from both sides to make the right side 0. Alright, 2 minus 2 cancels out. I have a negative 2 sine squared x and a negative sine x. So I'm going to factor a negative sine x out. That leaves me with 2 sine x plus 1. And then if negative sine x equals 0, dividing by a negative 1, I still get sine x equals 0. If 2 sine x plus 1 equals 0, subtract 1 and divide by 2 to get sine x equals negative 1/2. So I only want the answers between 0 and 2 pi. So sine x equals 0 at 0 and pi. And then sine x equals negative 1/2 at 7 pi over 6. 7 pi over 6. And at 11 pi over 6. Alright, problem 29. We changed our interval to be negative 2 pi to positive 2 pi. So that basically means give me the answers on the regular unit circle, then give me those same spaces on the unit circle, but travel backwards and label them as negative answers. Alright, I have to isolate the cotangent, so I'm going to add 1 and divide by 3 to get cotangent squared x equals 1/3. Then I'm going to do plus or minus the square root, so I get cotangent x equals plus or minus square root of 1/3. The square root of 1 is 1, and the square root of 3 is root 3, so it's plus or minus 1 over root 3, which I can rationalize. So I get cotangent x equals plus or minus root 3 over 3. Alright, so on the unit circle, I'm looking for the places where x over y is root 3 over 3 or negative root 3 over 3. So just on the positive unit circle, there should be 4 places. And this is going to happen at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now to find the negative answers, you can either travel backwards on the unit circle to figure out what those spaces would be, or you can subtract 2 pi from all of these answers. So if I subtract 2 pi from pi over 3, I get negative 5 pi over 3. No, let me fix that. If I subtract 2 pi from 2 pi over 3, I get negative 4 pi over 3. If I subtract 2 pi from 4 pi over 3, I get negative 2 pi over 3. And 5 pi over 3 minus 2 pi gives you negative pi over 3. So 8 answers altogether. Problem 30 actually has a ton of answers, and here's why. If you go 4x, then you're going to get 4 times as many answers as usual. So even though we're only on 0 to 2 pi, we're going to get 4 times as many answers. So that would be 4 times 2. I would normally get 8 answers. But then also, because of the squared here, I'm going to get plus or minus. So I'm expecting to get 16 answers from this problem. So prepare yourself for that, and let's write this problem on a separate sheet of paper. Let's see what we got. Here we go. So 5 cosecant squared 4x equals 10. Divide by 5 to get cosecant squared 4x equals 2. And then square root cosecant 4x equals plus or minus root 2. So cosecant's reciprocal of the sine, so that means that the sine of 4x equals plus or minus 1 over root 2, which rationalizes to be plus or minus root 2 over 2. So there are 4 spots on the unit circle. That would be 4x equals pi over 4 plus 2 pi k, 4x equals 3 pi over 4 plus 2 pi k, 4x equals 5 pi over 4 plus 2 pi k, and 4x equals 7 pi over 4 plus 2 pi k. So multiply all your answers by 1/4, or think of it as dividing by 4, and you get x equals 1/4 times pi over 4 is pi over 16. 1/4 times 2 pi k is 2 pi k over 4, which simplifies to pi over 2. So 2 pi over 4 simplifies to pi over 2. This one, 3 pi over 16, and again this is going to be pi over 2k, and 5 pi over 16 plus pi over 2k, and 7 pi over 16 plus pi over 2k. Okay. So one set of answers is pi over 16, 3 pi over 16, 5 pi over 16, 7 pi over 16. But we're going to add pi over 2 to these answers 3 times to get 3 more sets of answers. So pi over 2 with a common denominator of 16 is going to be 8 pi over 16. So I'm going to add 8 pi over 16. So if I add 8 pi over 16 to this one, I get 9 pi over 16. And if I add 8 pi over 16 to that one, I get 17 pi over 16. And if I add 8 pi over 16 to this one, I get 25 pi over 16. Alright, and I want to write my original, the pi over 16, let's write that without the general form, so just pi over 16. Alright, I'm going to add 8 pi over 16 to this one, so that's going to give me 11 pi over 16. Add 8 pi again to get 19 pi over 16. And add 8 pi over 16 again to get 27 pi over 16. And then let's put the original 3 pi over 16 down here as well. Alright, 5 pi over 16 plus 8 pi, 13 pi over 16. Plus 8 pi, 21 pi over 16. Plus 8 pi over 16 29 pi over 16. And plus 8 pi over 16 will give us 37 pi over 16. Oops, that's too big. Right, I added too many times. 1, 2, 3. Get rid of this last one. And down here, let's just write the original 5 pi over 16. Alright, 7 pi over 16 plus 8 pi over 16 is 15 pi over 16. Plus 8 pi over 16, 23 pi over 16. Plus 8 pi over 16, 31 pi over 16. And if you add 8 pi over 16 again, it gets to be too big, so we're just writing our original 7 pi over 16. So this equation actually did have 16 answers, as we predicted. Alright, give yourself a pat on the back after that one. Give yourself a smiley face and a star. Good job. Alright, let's go back. Alright, this one's on a separate page. I don't know why that's not writing. Separate page. Okay. 31, it looks like we need to do another quadratic substitution, another Pythagorean substitution. So this time we have a cosine squared, which can change to a 1 minus sine squared. It's actually exactly what happened in the problem above. So I have 3 sine x plus 3 equals 2, parentheses 1 minus sine squared x. And 3 sine x plus 3 equals 2 minus 2 sine squared x. Let's get everything to the left side. So I'm going to add the 2 sine squared x to move it over here. Plus 3 sine x. And then I'm going to subtract the 2 to move it over here, so that's a plus 1. Alright, and this time, instead of doing a u substitution, which will completely work for you, I'm just going to do a guess and check. So I know that 2 sine x, that's going to have to be, 2 sine x squared has to be 2 sine x times 1 sine x. And a 1, that has to be a 1 times 1. So I'm going to just check and see if this works. 2 sine x times sine x gives you 2 sine x squared. I have 2 sine x times 1 and 1 sine x times 1, and those add up to give you the 3 sine x, and 1 times 1 is the 1. So guess and checked worked for me here. This factor, when I set it equal to 0, is going to give me sine x equals negative 1/2. And this factor gives me sine x equals negative 1. So these are both negative values for the sine, but I only want answers from 0 to pi. So from 0 to pi, that's up here where the signs are positive. So in this case, there are no solutions from 0 to pi. Okay, so you just want to write no solutions from 0 to pi. There are solutions, but not on the interval that we're given. All right, in the calculator section, you need to check and see how you're supposed to be giving your answers. So the first section, it says to give your answers in radians. Now first, before we go to the calculator, let's plan what we're going to write out for each one. There's an inverse tangent button on the calculator, so that one's fine. But if you want to do a cosecant, cosecant is 1 over the sine. So you'll be typing 1 divided by the sine of inverse tangent. And actually, let's keep our whole denominator together with an extra set of parentheses just in case. 1 divided by sine of inverse tangent 1.456. Close these parentheses again and again. So I have 1, 2, 3 opens, 1, 2, 3 close. That's what we're going to put in our calculator. 33, there's an inverse sign button on the calculator, so we can enter this exactly how we see it. And for 34, we have an inverse secant. When you do inverse reciprocal functions, it's not going to be 1 over the cosine, it's going to be 1 over the input. So it's going to become inverse cosine, and then 1 divided by 2.3456, like that. Alright, so that's exactly what we're going to put into the calculator. We're going to check and make sure we're in radians first. Okay, let's see. First problem, mode. So I need to go down and put this in radian mode. And quit. So let's do 1 divided by sine. Inverse tangent is second tangent. And I'm going to need my decimal, so I need to raise this just a little bit. 1.456 and close, close, close. Actually, did I have 3 opens? Oh, I never put one up here. You know what? I'll close it and I'll go back up here and do second, insert, and there. So I have 1 over the sine of all of this. Let's see what it tells us. Alright, so it tells us 1.213, and it does not tell us how to round these answers. I'm just going to round them to the 10th place because that's how it's done on the answer key. So I'm going to write 1.2 for this one. Okay. The next one we can enter exactly as we see it. Alright, inverse sine, negative 0.9876. So approximately negative 1.4. And while we're at it, let's put in what we said we were going to type for 34. So we said we were going to change it to inverse cosine and do 1 divided by 2.3456. Okay, so we get approximately 1.1 for that one. So I'm going to put those answers in. Alright, down here, we're going to find all of the solutions to these equations from 0 to 360 degrees. So remember that the inverse trig is only going to give you one solution, and we have to figure out the other solutions. This time it tells us to round to the nearest hundredths place, so we'll do that. And it also tells us that we're working in degrees, so we need to change our calculator mode back to degrees. So let's clear what we have, and we need to go mode and go down to degrees. Alright, so I'm going to end up doing the inverse sine, second sine, of negative 0.2345. And this is going to tell me that one angle that has a sine of negative 0.2345 is negative 13.56 degrees. So let's figure out where that's going to be. Okay. So this angle down here is negative 13.56 degrees. But I only want answers between 0 and 360. Now I do know that sine is negative also in the third quadrant. So this is where my angles are that have a sine of negative 0.2345. But I want to name them both as positive angles. So let me go back to this one first. If I add 360 degrees to this, I'm going to find the coterminal angle plus 360, and that's going to give me 346.43 degrees. So this angle is 346.43 degrees. Now I also want to know this angle here. I know this part is 180, and I know this part is 13.56. So I'm going to add this together. 180 plus 13.56, and I get my second angle is 193.56 degrees. So 2 answers. Alright, in 36, the cosine of 2x is negative 0.6 0.67. So I'm going to do inverse cosine on both sides, and I'm going to type that on the calculator. Inverse cosine negative 0.67. Alright, so I get 132.07 degrees. And where is that going to be? Somewhere around here. So this is 132.07 degrees. Alright, so there's another place that's going to have a cosine of negative 0.67, and since cosine is negative in the third quadrant and the fourth quadrant, this is the other place. Now I need to find this reference angle in here by subtracting 132.67. I need to subtract that from 180 to find this piece in here. So in here, 180 minus 132.67 gives us 47. Let's see. Oh, I said 0.67. This is actually 0.07. Sorry. So it's 47.93. And that means this reference angle is also 47.93. So I already know that 2x is going to equal this angle, 132.07. And to find the other angle here, I'm going to add 180 plus 47.93, and I get 2x equals 227.93. Okay. Now to find out what the x equals, I need to start with the general solution. 132.07 plus 2 pi k, which is 360k. 227.93 plus 2 pi k, that's 360k. These are 2x. 2x equals. So then, divide by 2, and we get x equals 66.035, which rounds to 04, plus 180k. And x equals 113.97 plus 180k. So these are two of our answers, 66.04 degrees and 113.97 degrees. And then if we add 180 to each of these, we'll get two more answers. The first one I get is 246.04 degrees. And then the second one, when I add 180 to 113.97, I get 293. Oops, I need 293.97 degrees. Okay, and that is the end of the review. Please make sure you've checked and corrected all your work.